Welcome! This is my monthly report for October of 2020 on the status of activity of solar cycle 25. It's been quite an exciting month. We've had several large groups of sunspots go across the sun, and in fact I show two of them here in the background. Each of these sunspots are about the size of the Earth. We've also had quite a number of flares, many from these two regions, and also some coronal mass ejections. We also had a comet crash into the sun, so all in all it's been a very active month. So let's get to it. So let's go over what we're going to talk about today. First, the onset of solar cycle 25 seems to have occurred in this month, October of 2020. Now I should explain what onset means. This is a term that a colleague and I coined during the beginning of the last solar cycle to indicate a sudden increase in magnetic activity, which led to new sunspot regions and flares suddenly increasing over the solar minimum conditions that had preceded it. Now that was exactly 11.1 years ago, so this is exactly one solar cycle later. So I think that we've justified this onset idea, which at the time was dismissed as coincidence or just happenstance. We've had 21 regions that have produced a visible sunspot of some sort. No matter how small or how short a time it lasts, 21 regions produced sunspots. So actually there were no spotless days as far as I can see during this month. 16 flares occurred greater than C1 and several CMEs, as we shall see later. We had a comet crash into the sun, which I mentioned earlier. Predictions went well. I do a Twitter feed for instantaneous feedback on what's going on the sun, and during that I sometimes make prediction about whether flares are going to occur or a filament's going to lift off, and most of those predictions went pretty well last month. And what's more is we have two new regions seemingly to come over the east limb of the sun, and so this level of higher activity may well continue even after the regions that are currently on the sun rotate off. But we'll have to wait and see what these new regions look like before we start counting those particular chickens. First, let's deal with sunspots. And here is the official sunspot number from the Solar Influences Data Center in Belgium. And you can see that the number of sunspots have been increasing throughout the month. The sunspot number even reached 40 at one point, which is the highest it's been for a very, very long time. The average sunspot number for the month was 13, and that is again a large increase over previous months. And according to this record, there are only 8 spotless days, but they count the sunspots differently from the way I do. Those sunspots have to be a certain size, have to be on the sun for a particular length of time, and so on. If you go by the method that I use, there were no spotless days during this month. Here is the sunspot number over the last 13 years. Yellow are the daily records, blue is the monthly average record, and red is the smooth sunspot number. Let's put on there the new data point, that's there, and that's the highest sunspot number for nearly 2 years. And that was during the decay of solar cycle 24. Solar minimum has been defined as December of 2019, though I think it might be a month or two earlier than that, but they've defined it, so that's I guess what we're going to have to stick with. And the sunspot model best so far is the SC model, which indicates a lower solar cycle. However, we could be exceeding that fairly shortly if this sort of level of activity continues. I've put this number of sunspot groups into graphical form here, contrasting the number of regions we've had from solar cycle 24 to those from solar cycle 25. You can see even now we're getting the odd solar cycle 24 region. In fact, we had 2 of them this month, but they were both very small single spots and short-lived, just lasted for a few hours. On the other hand, we had 19 new cycle regions. They were mixed, some small, some large, and some long-lived and some short-lived. But nonetheless, there were 19 of them. And you can see how that number has been increasing over the last few months. Now let's take a look at a movie of the sunspots. This is using the Solar Dynamics Observatory magnetic imaging device in its continuum channel. On this movie, 1 day equals 1 second, so it's very much speeded up. And most of the action you'll see is in the south, but there are a few regions that do appear in the north if you're quick enough to notice them. So let's go to the movies. As you may know, sunspots are just magnetic features on the sun. So this is a movie of the magnetic sun. These are from the SDO HMI magnetograms. Again, 1 day equals 1 second. Now, how to read a magnetogram. Positive magnetic field, that's outflowing magnetic field, are the light areas. Negative magnetic field, that's inflowing magnetic fields, are the dark areas. You'll see a lot more activity here than in the sunspot movie because not all regions produce sunspots, or the magnetic field from these regions lasts longer. The magnetic field comes up first before you see sunspots, and after the sunspots have died away, the magnetic field can reside there for months. So look out for regions of particularly intense dark and light areas next to one another, and those are likely sunspot regions, or they are regions that don't quite make the sunspot threshold. As I mentioned earlier, we've had an unusually large number of flares this month, and we got 14 C flares in just a 72-hour period. 9 of those were from active region 2778, that's the large region in the southwest, and 5 of those were from active region 2779, that was the small region that grew up just to the north and east of 2778, and they started to interact with one another, as I'll show later. Flare activity seems to be on the increase. Shown here is the flare activity from solar cycles 24 and solar cycles 25 so far. We had fairly regular flares in solar cycle 24 up until about May of 2019, when all activity just seemed to stop. In May of this year, we started to get some activity from solar cycle 25. We had 1 M flare, which is quite impressive, and 2 C flares, and then in the subsequent months either no activity or just 1 or 2 flares. But in October of 2020 we've had 16 C flares. That's just amazing. And so we have to go back over 2 years to find a month that has had equivalent number of flares in it. So this really shows how much flare activity has increased just in this last month. Okay, let's take a look at some flare movies. We're going to use the Solar Dynamics Atmospheric Imaging Array. It's 131 channel. Now, what you'll see is that none of these flares are particularly spectacular, but you'll see very bright kernels appearing in some of the active regions, and those are the flares. See if you can count them. These are going to be full disk images, and again 1 day equals 1 second. So enjoy. Now let's take a look at those 2 active regions 2778 and 2779, interacting with one another. Note how quickly, once 2779 appears, the 2 regions create magnetic bonds between them and start interacting. We're going to use the Solar Dynamics Observatory AIA instrument 171 channel to show this particular movie. Often associated with flares are coronal mass ejections, although they are technically different things. So we'll take a look at that using the Soho-Lasco C2 and C3 instruments. So what you want to do is look to the left and right, that's the east and the west limbs respectively, and look for eruptions off the disk. Now this is often for regions that are behind the limb, so these may be flares that are occurring that we don't see on the main disk. So there may be more activity around than you're looking at. There's also the comet crashing into the sun. You'll see that come in the bottom right hand corner. However, I'm going to give you a much better view of that in the next movie. Now let's take a better look at that comet crashing into the sun. The comet approaches from about 5 o'clock and dives into the sun and doesn't survive. I did a detailed video on this in the links below, so if you want to take a look at the more detail on the comet, you can there. But in the meantime, we'll just show the clip itself. On the 22nd of October, I predicted that a filament on the northeast limb of the sun was likely to erupt. You'll see in the movie that I'm about to show that filament is the dark material standing way up above the limb. As we look at it, it gets more and more dynamic. It also gets darker, which means it's getting denser. And then it also gets taller. So it's becoming unstable and eventually lifts off. I made a number of lucky and perhaps accurate predictions this last month, and you can see those predictions that I make on Twitter. All you need to go to is drkstrong is my Twitter account, and I do daily or hourly updates on what's going on the sun and other things. On the 14th of October, I predicted that we'd get some C flares. 2 days later, we got 3 C flares. On the 25th of October, I predicted C flares, and on the 27th we got 4 C flares, and on the 28th we got 5 more C flares, and that was from the region 2778. On the 28th of October I predicted more C flares because of the emergence of that new region, which turned into 2779, and on the 29th of October we got 4 C flares from the new region as predicted. So I'm rather proud of those predictions, or just maybe it's time for me to buy a lottery ticket. But as they say in some of those cheesy ads, that's not all. We have 2 new regions coming over the east limb, and if they prove to be significant regions, our level of activity could continue for some time as yet. Maybe they're the decaying remnants of some regions developed on the far side of the sun, or maybe they're newly developing regions. We'll have to wait and see as to which they are. They were there 3 days ago, so they're probably not that new. And you can see that on the stereo A image. Another interesting thing you can see from the stereo image, here you can see on stereo's west limb, which is near sun center or past it, that the 2 regions on the disk at the moment are connected across the equator. So we have interaction between the northern and southern hemisphere, and that's very early in this cycle for that sort of thing to be happening. It's probably just coincidence that these regions are sufficiently close together in longitude to be able to do this, but nonetheless it's still an interesting development. So, what can we conclude from all of this? Solar cycle 25 is well underway, and it seems that the predictions for a grand solar minimum this time around are not going to work. So I suspect they'll start shifting their predictions back another solar cycle, so we have another 11 years of that nonsense. We seem to have had an onset event, just like we had for solar cycle 24, which is making a colleague and I feel very justified in our conclusions from the last solar cycle. We expect bigger sunspot regions to emerge in the coming months and for them to last much longer. The northern hemisphere is still lagging behind the southern hemisphere by several months. So I'm not prepared at the moment to change my forecast of solar cycle 25 max being somewhat larger than solar cycle 24, but I might up that estimate if the lag and the activity continues to be as it is currently. So until next time, stay safe. I'll see you again soon.